Lesson 5, Normal Probability Distribution. A normal probability distribution is a probability distribution of a continuous random variable. It shows graphical representations of random variables obtained through measurement like the height and weight of the students, the percentile ranks of the A&E test result of the AL students, or any data with the values of interval scale of real numbers. It is also used to describe the characteristics of populations in making inferences. So basically, normal distributions are the data we get from a population or a sample. And we also need to distinguish between a parameter and a statistic. A parameter is a number that describes the data from a population, while statistic is a number that describes the data from a sample. Examples of a parameter in statistics are the mean and standard deviation, and we have to be very careful with what symbols we use to represent these numbers. When we are dealing with a sample, we use the x bar to represent the sample mean, and we use the small letter s to represent the sample standard deviation. These are statistic. When we want to represent the population, we use the Greek letter mu to represent the population mean, and the Greek letter sigma to represent the standard deviation. These are parameters. The population parameters mu and sigma are very important when we talk about normally distributed populations. This is the graphical representation of a normal probability distribution and is popularly known as the normal curve. This will help us describe our data from a population and make inferences about it. Now let's go to the properties of a normal curve. Number 1, the distribution curve is bell-shaped. So looking at the graph, it is of a shape of a bell. Number 2, the curve is symmetrical about its center. From the center of our normal curve, we know that the right side and the left side has equal measurements. In short, they are symmetrical and they are balanced. Number 3, the mean, the median, and the mode coincide at the center. So looking at our graph again, the mean there is equal to 0, and the mean, the median, and the mode, they coincide at the center. They have the same value. So the mean is equal to the median, and it is also equal to the mode. Number 4, the width of the curve is determined by the standard deviation of the distribution. To understand further, let's look at this graph. This is the graph of a normal curve. So the B here at the side represents the mean, and the A represents the standard deviation. Now, if we move the mean to the right, we'll see that our normal distribution also moves to the right. A higher value of the mean indicates that the normal distribution shifts to the right, and a smaller value of the mean indicates that the normal curve or the normal distribution shifts to the left. So the mean, it just moves, it doesn't change its shapes or size. It just moves to the left or to the right. Now let's go to the standard deviation. A higher standard deviation means the width of the curve is wider. So the standard deviation determines the size of your normal curve. A bigger value of the standard deviation, we can see that the normal curve that the normal curve became wider. And if we have a lower standard deviation, we'll see that the normal curve becomes narrower at the center. For the fifth property, the tails of the curve flatten out indefinitely along the horizontal axis, always approaching the axis but never touching it. That is, the curve is asymptotic to the baseline. Looking at the graph, we can see that the line here in the curve never really touches the baseline but is always approaching it, just getting closer and closer but not really touching it. Number 6, the area under the curve is equal to 1. Thus, it represents the probability or proportion or the percentage associated with specific sets of measurement values. If we look at the graph, no matter how big or how small the distribution or the normal curve is, its area is always equal to 1. When the normal probability distribution has a mean equal to 0 and standard deviation equal to 1, it is called the standard normal distribution. Now let's go to the empirical rule. The diagram here shows the representation of 68, 95, 99.7% rule. This rule is better known as empirical rule. This rule states that the data in the distributions lies within the 1, 2, and 3 of the standard deviation of the mean. So, the empirical rule will help us approximate the percentage of data within a specific score set. So, specifically, this diagram tells us the estimation of the following percentage. 68% of the data lies within the first standard deviation of the mean, the green colored there in the diagram. 95% of the data lies within the 2 standard deviation of the mean. It is the red colored standard in the diagram, and 99.7% of the data lies within the 3 standard deviation of the mean. You can see there the black color, that is 99.7% of the data. Now let's have this example to understand further. The score of the senior high school students in their statistics and probability quarterly examination are normally distributed with a mean of 35 and standard deviation of 5. Answer the following questions. What percent will fall within the score 30 to 40? What scores fall within 95% of the distribution? So for our solution, first we need to list the mean is equal to 35 and the standard deviation is equal to 5. Now let's draw the normal distribution representing what is given. So our mean is 35, and to find the values of the 1, 2, and 3 standard deviation from the mean, we just add 5 because 5 is the standard deviation from the mean. So for the first standard deviation to the right, we add 35 plus 5, it is equal to 40. Second standard deviation to the right of the mean plus 5 equals to 45, and add another 5, that's 50. Now let's go to the first, second, and third standard deviation from the mean to the left of the distribution. So 35 minus 5 is 30, and minus 5, that's 25, minus 5, that is 20. Now there's our normal distribution. Now let's have the first question. What percent will fall within the score 30 to 40? So if we locate 30 to 40 on our normal curve, it is in here. So we can find it using the empirical rule. It is in the first standard deviation from the mean, and it is equivalent to 68% of your whole data. Therefore, our answer would be the scores 30 to 40 falls within the first standard deviation of the mean. Therefore, it is approximately 68% of the distribution. Now let's have the question number 2. What scores fall within 95% of the distribution? So if we still remember the empirical rule, 95% of the distribution represents the data that are second of the second standard deviation from the mean. So we have here 25 to 45, that is 95% of the data. So our answer would be, since 95% lies within the 2 standard deviation of the mean, then the corresponding scores of this distribution are from 25 up to 45. Let's have the second example. EQ scores of grade 11 students in the division of Bohol are normally distributed with a mean of 90 and a standard deviation of 15. Answer the following questions. What percent will fall within the score of 60 to 105? And what percentage of the data is the score 75? So for our solution, we know that the given is the mean is equal to 90 and the standard deviation is equal to 15. Now let's draw the normal curve. Our mean is 90, so for the first standard deviation from the mean is 105 plus 15, 120 plus 15, 135. And to the left of the distribution, 90 minus 15 is 75, minus 15 is 60, and minus 15 it's 45. Question number 1. What percent will fall within the score 60 to 105? Now here's our score 60 to 105. So going back to the empirical rule, we can see here that within the first standard deviation is 68% divided by 2, that's 34%. And right there we have 13.5% for the half of the second standard deviation. So if we add 13.5 plus 34, it's 81.5% of the distribution. Number 2, what percentage of the data is the score 75? So there's the score 75, and it's at the left of the mean. And looking at the empirical rule, that is 34% of the data. So that would be our answer. Now let's have an activity. True or false? In the answer sheet, let's write the word true if the statement is correct and false if it is incorrect. 1. The total area of the normal curve is 1. The correct answer is true. Number 2. The normal probability distribution has a mean equal to 1 and standard deviation equal to 0. That is false. 3. The normal curve is like a bell shape. It's true. The curve of a normal distribution extends indefinitely at the tails but does not touch the horizontal axis. The answer is true. And number 5, about its mean 0, the normal curve is not symmetrical to the center. The correct answer is false. Now, I hope you learned something from this lesson. Always remember to have a statistic amazing day. Have a good day.